For years, the virtual DOM has been hailed as the ultimate performance optimization for the modern web. We were told that the real DOM is slow and that by creating a lightweight JavaScript representation of our UI, we could bypass those bottlenecks. This narrative propelled React to industry dominance, making the virtual DOM a household name in software engineering. But here is the uncomfortable truth. The virtual DOM is not a performance feature. It is a functional requirement for a specific programming model. It's an overhead that frameworks must pay to support a top-down, declarative approach where everything re-renders on every state change. As our applications grow more complex, this overhead becomes a tax on our users' CPU and battery life. Today, we're going to look at why the fastest virtual DOM is actually no virtual DOM at all, and how the industry is shifting toward a more surgical approach to UI updates. To understand the lie, we have to look at what happens when state changes. In a VDOM-based framework, a change to a single variable triggers a full re-render of the component. The framework creates an entirely new tree of JavaScript objects representing the UI. It then compares this new tree with the previous one, a process called diffing or reconciliation. This diffing isn't magic, it's work. The framework has to traverse the entire tree, checking every prop and every child to see what changed. If you have a list of 1,000 items and you update one character in one item, the framework still has to iterate through all 1,000 virtual nodes just to find that single difference. We are doing O of n work for an O of 1 change. While JavaScript engines are fast, this work adds up, especially on low-powered mobile devices where every millisecond of main thread activity counts toward a janky experience. Beyond CPU cycles, the virtual DOM places immense pressure on the browser's memory. Every time a component re-renders, thousands of objects are created and then immediately thrown away. This creates a massive amount of garbage for the browser to collect. Garbage collection is a stop-the-world event. If the GC kicks in during a critical animation or a scroll event, the user sees a frame drop. We've become so accustomed to huge bundles and complex runtimes that we forget that the most efficient code is code that doesn't run at all. By allocating and deallocating memory so aggressively, VDOM frameworks are constantly fighting against the browser's natural resource management. This is why highly interactive apps like spreadsheets or design tools often hit a wall with traditional VDOM frameworks. The sheer volume of object churn becomes unsustainable. But if the virtual DOM is a lie, what is the truth? The truth is that we can achieve the same declarative developer experience without the runtime overhead. Frameworks like Svelte and Solid have pioneered a compiler-first approach. Instead of shipping a heavy diffing engine to the browser, they analyze your code at build time. They see exactly which parts of your UI depend on which pieces of state. Instead of creating a virtual tree and diffing it, the compiler generates surgical JavaScript that updates the DOM directly. It's like having a custom-built update function for every single variable in your app. When the variable count changes, the framework doesn't ask what changed in the UI. It already knows exactly which text node needs to be updated. This moves the complexity from the user's browser to your build server. This new paradigm is called fine-grained reactivity. In this model, state variables are not just values, they are observables that components subscribe to. When a piece of state changes, it triggers a chain reaction that leads directly to the specific DOM element that needs to change. No diffing, no virtual trees, no reconciliation. Think of it like a spreadsheet. When you change a cell, Excel doesn't recalculate every single cell in the entire workbook. It only updates the cells that are mathematically linked to the one you changed. Fine-grained frameworks bring this same efficiency to the web. By eliminating the middleman, the virtual DOM, we reduce the amount of JavaScript shipped to the client and ensure that the browser only does the absolute minimum amount of work necessary to reflect the state of the application. Does this mean React and the virtual DOM are obsolete? Not necessarily. The virtual DOM provides a powerful abstraction that allows for features like cross-platform rendering. Think React Native. It also simplifies the mental model for developers by treating the entire UI as a pure function of state. For many applications, the VDOM overhead is negligible. If your app is mostly static or has simple interactions, the lie doesn't hurt you. But as we push the boundaries of what's possible in the browser, with complex data visualizations, real-time collaboration tools, and high-performance dashboards, the choice of framework matters more than ever. We are entering an era where performance is no longer an afterthought, but a core architectural decision. Understanding that the virtual DOM is a choice, not a necessity, is the first step toward building faster, leaner web applications. The virtual DOM is a lie isn't about calling React bad. It's about dismantling the myth that it's a performance silver bullet. As we look forward, the frameworks that win will be those that minimize the gap between your code and the browser's native capabilities. Whether through compilation, fine-grained signals, or direct DOM manipulation, the goal remains the same: a seamless, high-performance experience for the user. The next time you start a project, don't just reach for the industry standard because of its marketing. Look at how it handles updates, look at its runtime cost, and ask yourself if you really need a virtual middleman. The future of the web is faster, lighter, and more direct. Thank you for watching.